Hi everyone, welcome to another Common Lisp Study Group. I'm your host Ram Vedam with Atlanta Functional Programming. Last week we covered our basic experiment and introduction to the CFFI here at the Common Lisp Study Group. As I mentioned before last week, the CFFI, the form function interface that is provided for you to essentially hook into other external libraries, was designed particularly to allow shared libraries and of the sort that were written in external languages such as C to be able to be loaded into a Lisp image. I mentioned last time that the C name mangling scheme in the ABI was kind of the basis for a lot of loading, and if we end up using that in a general sense to other external languages that support this name mangling scheme to allow themselves to interoperate with C libraries themselves, we could certainly then see then that we could in many ways extend that notion of loading external libraries, not just to C, but to other languages that support the C name mangling scheme when creating shared libraries and or even maybe archive files, although I mentioned last time I believe archive files or static libraries as it stands today cannot be loaded unless someone can correct me if I'm wrong. I just didn't see it in the documentation for CFFI. In today's discussion, we're going to continue our experimentation with this notion and see if we can use other languages to load into Common Lisp. And again, I'm going to be focusing on pure functions with primitive types just for the sake of simplicity, although I'm going to try and see today, time permitting, if we could end up creating a more complex example that could take a Lisp object back and forth from the external language into C and vice versa, just for the sake of, kind of showing that this can be done. Obviously, this isn't a exercise in language or library design, and kind of picking languages that I know or have some experience writing, so that way we could keep things fairly simple and fairly easy. Of course, if there are other languages that you may or know that can compile into compiled code and can support the interoperation with C, you can certainly do this experiments amongst yourselves in those external languages. So our agenda today, as I am presenting to you, is first going to go ahead and cover this kind of technique that I kind of just mentioned. Additionally, I wanted to talk about the second aspect of calling Common Lisp code from other languages. Now, I'm going to be very specific about it. This vanilla that I call here in this point is mainly without using any sort of external libraries, because as you can see in the third point, I'm also going to try and introduce to you SBCL-Librarian, a package that I recently stumbled upon when I was going on this adventure that I mentioned last week, that in some weird sequence of fate, it turned out others were also looking at, because as soon as I finished the stream last week and I started doing more digging, I ended up realizing that the Common Lisp Cookbook actually was drafting a tutorial on how to use this library to write bindings for C and Python, because SBCL-Librarian, as I mentioned last week, actually gives you the ability to quickly create C and Python bindings using their externals. They actually wrote an API to allow you to define an API that can then subsequently spit out a header that can be then included in C objects and C libraries and so forth. And additionally, if you call out build Python bindings, I believe is their API call, it'll end up also doing the equivalent in creating the appropriate Python headers and C files that can be compiled, because of course when you're writing these kinds of system libraries and external libraries with Python and creating Python bindings, what's going to end up happening is ideally, if you want it very efficient, you would end up not necessarily writing pure interpreted Python, but you'd end up probably using the PyObject API that's given to you so that you could end up hooking into other external libraries that you may want to use. And additionally, you will end up being able to use system-level programming constructs that's there and still be able to serialize and deserialize your Python objects and be able to interact with normal Python scripts in the Pythonic way by using the PyObject API directly. All right. I'm going to not focus on the PyObject API. Again, this is not a Python-based tutorial. I could certainly go through that when we need to talk about collections and things like this at the appropriate time. I'm just going to basically, again, as I mentioned earlier, focus on simple primitive types and just so that we can just see how this kind of interaction works in various languages. As usual, with all of our discussions here at the Common Lisp Study Group, this is somewhat of an informal discussion. I have a tendency to keep this kind of agenda up front, but by all means, for folks who are on the YouTube stream and or on our Jitsi channel, Jitsi study meetup, by all means, go ahead and ask questions in the chat, and I will answer them accordingly. Before I begin diving into particular details of today's agenda, I just want to make a couple of announcements. As usual, Atlanta Functional Programming is a meetup that kind of focuses on functional programming in its primary paradigm and try to, indicate talks that kind of highlight it in many different ways. If there is a topic that you wish to talk about that is kind of leveraging those kinds of techniques and being able to interact with FP languages or FP-like constructs in other languages, by all means, reach out to me. I'm available on both Functional Programming Slack, and I squat also in the Lisp Discord server as Bugram. Both my handles on both Slack as well as Discord is Bugram. Go ahead and DM me your topic name and we'll schedule you accordingly. Additionally, for those of you who are in the Atlanta area, because I know the YouTube live stream is international, AFP is in need of a new in-person home. We would like to be able to start having in-person meetups. We've been having some difficulty finding venues to host our meetups. If you have a particular place in mind, again, DM me, or you can write up a meetup message to me and my co-organizer, Judd Taylor, and we will reach out to those facilities so that we could start scheduling newer meetups in the upcoming future. Until then, a lot of our talks will then be recorded, and we'll still end up keeping this online venue because obviously, Common Lisp Study Group is always going to have its home at the Atlanta Functional Programming Meetup, and time permitting, we might end up reviving some of our other study groups as well. So, to start with, as I mentioned, the first topic is going to be calling other external languages from Lisp using the same CFFI technique. I mentioned last time, and as I mentioned earlier, that the C name mangling scheme support could be the basis to be able to call other external languages from Lisp. To illustrate this, I actually wrote, I hope this is still here, I may have done this in a different example. Let's see. Interesting. Did I not put that here? Hold on. Did I do it in here? Let me see if this hello.go guy is the one. So to start off with, I actually wrote a Go example for this, but it looks like this isn't the one. Okay, that's fine. We'll go ahead and create another one to illustrate this problem and to kind of show this technique. Why I chose Go is pretty obvious for many reasons, but the most important of which is I know Go, and additionally, given that we are talking about C, Go is a natural, garbage collected language. It's modern day. That's also written by the guys who wrote C. So it would be, a good homage to, or homage, or no, it's a homage. There we go. That's the word that I'm looking for. Homage to, the C, language. If we end up, picking its kind of like spiritual successor, as most folks kind of call it, to show how it can be loaded into Common Lisp. Now, to do this, let's go ahead and create a simple, did I put it in here? No, I did not. Okay, let's just go ahead and create a mymath.go file here. And actually, you know what? I'm just going to go ahead and do this instead. I'm going to do mymath and just keep mymath.go here. And let's go ahead and call this package main. And what we'll do is we will again do a standard function that we call add, and we do xy int, and it'll be an int, and then we just return a plus b, and then for the sake of completeness we do that. Alright. Now you might be wondering why I have a main function there. I've seen examples when they were creating these libraries for calling to C, where basically they have this blank main function in the actual what's the word that I'm looking for? Actual this main function, just so that it's kind of ignored this entry point. I think that's probably because of the fact that, if I remember correctly, the main reason is because because we made it into a package main, this is kind of the only way to kind of prevent the Go compiler from complaining that we don't have a main entry point. To actually go ahead and, but other than this is kind of your standard like library that you could end up kind of building inside Go. The one thing is this alone will not be complete, because this ends up creating, using the Go toolchain, a Go object that ends up having a different name mangling scheme. And when I talk about name mangling, basically when you generate an object code, your symbols that end up representing your functions are represented kind of like labels inside of the assembly code. And the way those labels are generated is a scheme called name mangling that tells the linker and additionally the runtime what code you're trying to actually reach out to. But additionally, if you're doing debugging especially, these name mangling schemes can be used as metadata to hook into the debugging infrastructure, so that without having the actual source code, they can actually tell you what the, for example, some simple things like what the signature of the function is. Alright, so this is somewhat useful for those things, but for our particular use cases, this isn't really much use, because we kind of want to unify ourselves to C. In order for us to do that, we need to go ahead and import C, and this C namespace is used to actually go and compile the code when we end up adding some annotations to our exported functions, and we'll be able to then call them when we build our shared object. Okay. So let's go ahead and do this. So all rules when it comes to exported functions, as far as I can tell, related to Golang, apply here. So that means your function names have to be capitalized, otherwise the Go compiler will complain when it tries to build a shared object. This is why add is capitalized, okay? Notice main is not capitalized, okay? To export add into C, in the final shared object, we need to do something called extern add, okay? And what this does is it's basically, think of it like an exported symbol, all right? So this guy will, oh, sorry, not extern, I'm thinking too different, export add. And you can think of this as like in C++ and or even in C, when you're doing an exported function symbol, you end up having to put some metadata next to the symbol or function signature. Usually it's like if you're using GCC, it's like dunder decal spec, if I remember correctly. And it's compiler specific, it's OS specific. There's a lot of rules around what calls you need to do. There's like DLL import versus whatever. Look at your platform's rules for exporting symbols and your compiler toolchain rules for more information. I can't really go beyond that just because that in and of itself is a talk on introductory library exported symbols. Once we do this and we have our exported symbol, okay, this export add is basically telling the Go compiler to create an exported symbol. We're now ready to actually go in and generate a shared object of this type, okay? Before we do that, let's go ahead and make sure that CFFI is properly loaded. Alright, now we could go and do this, and we could do eShell, which puts me in my math, make sure my math Go is available. There it is. Now we could use Go build to actually build the object. Now to create a shared object, you actually have to use something called build mode inside the Go tool. Build mode allows you to specify what ultimate artifact you want to generate. By default, if you don't specify build mode, you end up assuming to be generating an executable. Okay. In this case, we don't want an executable. We want actually a shared library. So we end up using build mode C shared to actually go ahead and build this guy. And we're going to just build mymath.go. Oh, right. Let me go back. I'm an idiot. I say A, B, and say X, Y. It does not matter, but let's go ahead and fix this. Okay. Build that. And when we generate it, you can see, where is it? Wait, did I forget to specify? Oh, I'm dumb. I forgot to specify here the actual object. We have to also specify -o mymath.so to generate the actual object file. Alright, so we now have our object file mymath.so. We could check that it's there. We could do it by using the nm symbols to look at the symbols. And if you go look up here and do add, you can see that our add function is a member of this runtime here. This is the type that we actually can see here, right? And we can also see that technically its signature is also available here as well. Okay, so we now have a shared object like generated for C from Go. Loading it is the same that we did last time. So if we want to load it, we first do CFFI, load, foreign library, specify the path here, software projects, Lisp projects, my math. So it's loaded. Now, just like I said before, last week, when you're loading now the C functions, you could certainly do this by creating what's the word we're looking for? By doing what we did before, which is using the wrong key binding here. Where was it? It was in hold on. Where is it? It was, there we go. Using CFFI, you have to specify the signature, obviously. So we do add, because it's a capital add, okay? And then we need to specify, I'm going to call it go add. And we need to specify the actual signature, so it's returning, a return type is int, its args is going to be a int, b int. Done. Okay, so now if we do go add 1, 2, 1, 3, we get 4, and you can see that it actually generates and loads up the symbols the way we kind of expect. Okay, this is regardless of whatever language that you are leveraging. All right, as long as you're able to compile to essentially the C symbols and export them as C symbols, you'll be able to load them into Common Lisp. No problem. All right. This is actually very useful, especially if you're experimenting with different libraries in different languages and you want to check them out. You could certainly do this. With Lisp objects like structures and enums and bit fields and things like this, you have to be a bit careful just to make sure that that piece is appropriately generated the way you expect it to, and we can probably go through some examples like that too as well. That's actually probably an interesting thing to do. Let's go ahead and do this. Let's see if we can do a more complicated example with an enumeration. All right. So give me just 1 second here. I have to remind myself about the. It's been a while since I've actually touched enumerations when I'm writing Go, so it's I have to remind myself of not so much the syntax, because it's just a type, but I always have to remember what the order is for doing this. Give me just 1 second. To go hunt down. Was not function. Right. So recall, I have to do this. That's right. It's a const. And we have to do, let's see, let's just check to see if we can do a season. And let's just say, winter, spring, summer, fall, and iota. And then we do this, do that. Wait. this is correct. I thought, hold on. I have to specify the type. Let's say int to make it easier. What is it complaining about? Int. Oh, right. This guy. Oh, wait. I don't need to do that. That's what I need to do. Thank you. I need to just make this type def into. Let me make this into. Let me do this. Type season int. And then this is season. Now we have that. Okay. And let us season, just so that we have it later on, and these should all be exported to as well at some point, but we'll deal with those exports at some point too, just so that folks can do it. And let's do this func get master season. Okay, let's do a switch on s do case enter, and we're just going to go ahead and write, you know, I think we have, I'm forgetting right now if I can actually convert this into a string or so forth, but it looks like I think I'm right about this. Do winter, and then do winter string, winter summer, and done. All right, and let's go ahead and convert this. Export get string. So this is now generated. So this is a little bit more complicated than what we've seen up until this point, mainly because of the fact that we're now dealing with an enumeration. We're now dealing with a function that takes in an enumeration, returns a string, and we'll be able to look at the interactions between this, particularly in Go. Okay. Okay. So there's a question here. You're doing Go. Yes. So to answer this, yes, I'm currently leveraging Go for showing external libraries, mainly because of the fact that I'm creating a library, a shared object. So I'm writing the stuff in Go, but I'm converting the shared object, converting the Go library into a shared object, a C shared object, following C name mangling, and then I'm loading that shared object into my Lisp image to show that as long as you can have the lowest common denominator as being your C symbols, you can load anything into Lisp, all right, using the CFFI as is today, all right. You don't have to worry about the respect of it because you're respecting C, and you'll be able to go back and forth no problem. If folks think that this is a bad idea, or if folks want to discuss, well, what are the advantages of it, by all means, ask your questions, and we can, start, talking about it. But my main focus here is to really drive home that Lisp today, as is, allows you to work on any language, any external systems language, can load any external systems language. Right? Common Lisp allows you to do all of this using CFFI today, as long as you're willing to compile your library to use the C symbols, all right, essentially the C ABI, and have it generate a shared object that respects the C ABI. This is already available in most systems programming languages as it stands today, because they all have to interoperate with C anyway. So this is one way to allow you to play around with those external libraries in Common Lisp without having to do any extra work. Does that make sense for folks? Any other questions on this? Any questions from our Jitsi audience? Okay, sounds like we're... Oh, okay, go ahead. Excellent question. So the question is for folks who are on our live stream who can't hear this, because unfortunately I haven't been able to hook up our Jitsi stream to our live stream, when and who would somebody build a library that does not respect the C naming convention? By default, a lot of compiled languages, for either simplicity's sake or what have you, or maybe more than likely when they're building it and they wanted to make things a little bit more consistent, they decided that they would not, they would generate their own kind of naming conventions. The advantages of creating your own naming conventions and creating your own shared object symbols is pretty obvious when you start thinking about what it means going to the C naming convention. All right, the C has a single global namespace. Most other languages want to have separate namespaces for their symbols, especially when you start talking about what I was saying before last week about this so-called prefixing, to allow you to have your own prefixed namespace inside C to make separate namespaces so you can use the same symbol across multiple libraries. If you're creating your own naming conventions, you could say, okay, I don't need to worry about that. I'm just going to go ahead and make it so that my naming conventions allow me to have namespaces. So this way, name conflicts can easily be dealt with at compile time, and as long as at parse time you see essentially kind of a namespace when you are parsing, you'll know that this is a different symbol from a different library. Bada bing, bada boom, you're good to go. But if you're using C, you don't have that luxury. So choosing to go to C so you can interoperate with C means you're sacrificing some conveniences that you have probably built into your languages so that you can interoperate with C. All right. There are other things also when you're interoperating with C, because of how old C is and its limitations, and for better or for worse, essentially for backwards compatibility, they didn't fix them. You end up having to write some of these kinds of workarounds to kind of stick with those C. That alone actually means that you're making some compromises in your library design, and by that itself, I am going to upfront say that this approach, if you are doing some very straightforward semantics, you can easily hit a situation where you're probably violating maybe some rules when you're crossing the external language to Lisp border, when you're interacting or interoperating with it, because the lowest common denominator that you leverage is C. My only response to that is unfortunately that is a known trade-off that most people have accepted when they're trying to interoperate with existing libraries without having to reinvent the wheel and rewrite. All right. And the way to deal with that is on a case-by-case basis when you're looking at larger system design. All right. You may be able to write safer guards and safer boundaries so that the unsafe boundary or the interaction between that C layer is minimized. And you can make it so that that boundary is like a protocol, so you could treat these as separate components, and you could copy stuff over and things like that to actually go ahead and interact with those types of that information safely in your own special world, separated. And then when you move it across the boundary, it's in this unsafe world only for a temporary amount of time. But that design itself also comes with costs, mainly because if you're thinking about larger objects, you might end up incurring very expensive copies. So again, it's going to be a case-by-case basis. I don't want to delve into some of the nuances of this, just mainly because it really depends on what you're doing. But I'm just going to end this with that this is kind of a known thing that you're going to have to deal with just in general, regardless of whether you're dealing with interacting with the external language with Lisp, or your external language is using some other C library that you want to bring in yourself. I'm just going to leave it at that. Another question. So you're using Go to prove you can... Yes. So I'm using Go to prove that I can interoperate with something other than C from Common Lisp. Yes, that is correct. All right. So let's see if this how this complicated example will work now. It's only slightly complicated, but it's still an extension that we should all be aware of. Okay, eShell. Go ahead and see if I could get this built again. Too many return values. Oh, wait, that's right. There we go. Missing return on line 29. Oh, right. I'm going to have to do a blanket one, aren't I? Okay. This should never happen, since we don't have a unknown or whatever. If you put anything that is not one of these four, it's not going to work anyway. Alright. But to make it happy, we're going to go ahead and do that. Alright. So we have our thing. Let's go ahead and load this library again. To make things nicer, it might be better for me to restart my Lisp just to make things a little easier. Okay. Let me also bring this down a little. There we go. Clear the REPL. CFFI load. Oh wait, I already have this somewhere. This. Alright. Okay, so we need to create a CEnum. Let us look at what the generated code looks like by looking at the so object. Okay, and look up summer. So get season has a string. Okay. All right. Okay, so now we have, okay, I think I can just go ahead and generate this as is. Okay, so let's do that. Okay, go here. Let's create a scratch buffer for this. Select scratch. And, hold on, it looks like there's a question. Oh, alright. And let's see here. Yeah, just go ahead and create this scratch buffer. Oh wait, I created it. Okay, so here, CFFI FC enum, yeah. And then here, I need to generate the enumerations. Hopefully this will all work the way I expect it to, but we shall see what happens. And we shall see how well this will actually work. Okay, let's create the okay, we'll create season, and I think I have to specify let's see if this works. Summer, winter. Oh wait, I may as well. Shoot, sorry. For some reason, my autocomplete on my Doom is something that I have to fix that I just have not had a chance to. I'm just making sure I match exactly kind of what we have. All right. We should have that. Let's see what happens when I do CFFI foreign enum keyword. This is kind of nice. Season 2. Good, summer. Alright. So now we have our enumeration. Let's go ahead and create our definition here. Hopefully this will also work. Call this defc function, and the exported symbol is get season as stir. The symbol itself is, let's call this I guess print season, just for the sake of making things a little bit more cleaner, because that's what we're ultimately doing on the Lisp side. And this is returning a string, and it's taking, and this is the more important thing, don't know if this is going to work, but we will see if it will. This, and let's see what happens. Compiled with error during macro expansions. Unknowns. Oh, right. Sorry. I have to probably do this. There we go. Let's look at what happens here. Okay, so it recognized that it's a key. Okay, good. All right. So let's see if this works. Print season, and let's do this should not work. Okay, this is throwing exactly kind of what I expected to. This is a character array error saying that it is systems time allocated sweep bad Alex. Okay, so this is doing some weirdness here then, because we do print season an actual. How do I allocate this guy? We'll see. Interesting. Okay, so it looks like although we created a shared object and we're returning a string, the Go garbage collector seems to be giving us some weird interactions. This is something I did not see when I built this originally, but we shall see what. There's something that I might be missing in terms of some runtime interaction when we're compiling stuff over. Give me a second here. I have to go look at this up. Okay, so I would have to probably generate. Oh, right. It's because a Go string is actually different, isn't it? Okay, so I can't actually use straight up string here. I have to create a Go string. So in order for us to do that, we're going to have to first do CFFI def c struct Go string, and this is going to hold a string, which is actually just an array of integers, and then an integer n. Go strings, unfortunately, again, this goes back to the fact that it's trying to map a Go object over. This is the kind of stuff that you will end up having to interact with and deal with when you're generating this stuff. All right. Give me a second here. This requires me to first look up the Go semantics just to make sure that I don't miss anything. Well, we'll see. Okay, so this one. This a string and then size 8. Okay, and let's go ahead and load. Oh, let me save this guy. This is probably pretty useful. AFP go mymath. And let's go ahead and do this, CFFI, load foreign library, and let's go ahead and put mymath dot. Oops, no, mymath.so3. Yes. Absolute path, don't I? Okay, hold on. Software. There we go. Okay. And this here. Do that. Go. String. gonna have to make this a bit more Lisp-like instead of trying to copy the, let's see if this works. You know what, this might be more useful if I go ahead and restart my Lisp just to be on the safe side. When you're dealing with stuff, that's one thing you'll notice, and you'll probably have to get into the habit of, is when you're dealing with stuff with foreign memory from external languages. General rule of thumb is you may want to just, as you're developing the library, if you made a mistake, your current Lisp image might end up getting messed up. So it would be probably useful for you to restart your Lisp image, or at least unload the foreign library and reload it, because this kind of constant reloading, I'm never really sure how the image reacts to that constant symbol loading, just because that's a piece, that inner working is Lisp implementation specific. All right, so yeah, so let's go ahead and quickly do this. Let's see, so reload, oh right, because I just first do a quick load, CFFI, now I can do this, loaded. Go ahead and do this here. And what is the error? Bare references to structure types are deprecated. Please use pointer. Okay, so let's do that. Okay. I don't know if this is going to work, but we will see. CPWR struct. There we go. And let's see what the maximum stuff is here. Okay. I don't know if this is going to. We will see. Okay. So let's do print season summer. Okay. Generated a pointer. But I need the value to that. Okay, hold on one second. I have to convert this guy to once I create the structure, I have to essentially print it out. So let me see how I can do that. I can do that with something called CFFI with foreign slots, right? Yeah, I think I have to do that. And the name of it is value size, because those are the names of the structure members. Then I have to specify the pointer, which here is star, and then star, for folks who are looking and just joining us, in Common Lisp REPL parlance, is the previously returned value. Of course, ideally, I may want to actually, let me first do this before I do this. Let me create a variable out of this, just so that way we can do a for and free after we're done. Value, set this to that. I'm just going to say RV. Alright, for standing for return value. So now, if we do, just make sure we have it. Yeah. Okay, so now we could do CFFI with foreign slots. We'll do value size pointer to go string, and let's see what it returns. Unhandled memory fault. Okay, so this is uninitialized memory, huh? That's kind of weird. Give me a second here. Let's see what the foreign size of this guy is. Foreign type size is what I need. Or is it the aref that I need to do? Let me see if I could use this foreign slot value. Okay, so we're going to have to do a little bit more work to actually get this C struct to work with Go types. It's not a big deal. Just means we're going to have to. Ideally, this is where unfortunately my macro skills is still up and coming. Let's just say that. Ideally, we would write a quick macro to actually generate all these types for us. For later viewing. Hopefully I'll spend some time today. This is just a mental note that I'll keep to myself for folks watching, that this might be okay, so there is a question. Okay. So for folks who are on the Jitsi, I see comments about the screen being tiny. You can actually select the user or screen that you're looking at, and it will maximize in the base workspace if you can't see it. So yeah, just giving other folks who are in there just a heads up. All right. Okay. Okay, so let me see if I can get this piece here going. This requires me to actually look at. Okay, so let me go look at usual in here. What is the string here? Error string, go string is there. So I'm going to have to figure out Okay, so in order to fix this error that we saw earlier, just to give folks who are just joining in a bit of an update, the thing that we're debugging is the fact that if you use just straight up string here, like so, okay, and you end up trying to use a call to, print season, passing in some basic examples, let's say summer, you end up getting the correct error return value here. But because Go strings, all right, Go strings are essentially being touched by the actual Go runtime that's hooked into the shared object library, okay? You have to actually do some hiding behind the scenes to make sure that the Go string object is appropriately owned by that piece of memory so that you can actually just return the string value and nothing else. So we need to essentially wrap that object. Go strings are actually an object inside of the Go runtime that contain the actual character memory, the allocated memory, plus the size. And we need to make sure that we appropriately abstract that object. So this is kind of the work that we need to kind of end up doing. Unfortunately, this looks like this requires me to actually creating a proper object to a struct, and I have a couple of other things that I wanted to discuss today. So I'm going to work on this on the side and kind of show this to you guys next week. This one piece on just wrapping this Go runtime piece into its own object, just so that you can have a more complete things, and I can give you some additional information in the meantime, if that's okay for everybody else who are watching on the stream. Okay, cool. All right. So the next topic that I want to discuss is I'm a bit excited about, just because of the fact that this seems to be something that in general, it's a topic that hold on, let me just pull that up here. It's a topic that I kind of wanted to know about myself for a long time, and that is how to call common Lisp code from other external languages, right? Because we now have the ability to obviously load in shared objects into our Lisp images. But what about the other way around? Obviously, we want to be able to take our Lisp code, we create this really nice fancy Lisp library that, probably does some fairly efficient things in the Lisp-oriented way. Not to say that it's going to be completely efficient compared to systems programming languages, depending upon how you could weed out certain bits and pieces of memory, but it's efficient in its own way in terms of doing stuff really cleanly, and you want to learn. Yes. I think this is one of the comments in the DC meeting is most appropriate. This efficient in terms of programming time. It'll improve programmer productivity. And you have this nice common Lisp library, and you want to be able to leverage it from other external languages. Now, up until probably a few years ago, all right, I don't know when they added this, your only choice for this is kind of leveraging commercial Lisp that's essentially compiled to shared objects, okay, shared libraries. So essentially, you could use something like, say, Allegro Common Lisp or LispWorks Common Lisp, which both compile to a shared object that you can load in, has a DLL into your application, leverage the shared object that you could load in, and then you'll be able to run your common Lisp code as is in your C program, or if you were so willing, you wrote a little wrapper that would allow you to load it into whatever other system languages of your choice. SBCL, I don't know when they added this. I'm actually very happy that they did. I just am still wondering when they did. they actually have now the ability for you to compile Steelbank Common Lisp has a shared object, which means you could do the same stuff that you could do with other commercial Lisps inside SBCL. I'm hoping this pattern isn't going to be just SBCL, and in the future we'll start hearing, like, say, Clasp or even Closure and other Lisps to be able to, like, load your Lisp core. And yes, I know that with embedded Common Lisp you might be able to do something like this too as well up until now. I just don't know what the exact approach is actually on embedded Common Lisp. I always thought of embedded Common Lisp's use case more in line with, say, Lua, which gives it the ability to embed itself into other host applications. If that's not the case, ECL folks, I'm sorry, I don't know. I've never used ECL regularly. I just used it like any other Common Lisp, which is both a benefit and a curse for me to kind of highlight the project. But that being said, this SBCL loading really surprised me, and I thought it would be useful to show you guys an example of us actually being able to create a simple piece of code from a vanilla standpoint, and then being able to load it. What do I mean by vanilla SBCL? Well, so vanilla SBCL really means without requiring the use of another package. And what are the costs of doing this will become apparent, okay? So I thought it would be best for us to first start out with that, okay? So to show you this, I'm going to go ahead and create a new Lisp file with what is necessary to actually first create a exported Lisp symbol that can be loaded as part of your Lisp runtime when you load it into your C application. Okay, so I guess that's a loaded explanation. I may have to dissect this a little bit. So let me be very specific. Okay, in any traditional Lisp application, okay, let's just talk about Lisp dump core when you do save Lisp and die, regardless of which Lisp. Okay, what ends up happening is a normal Lisp application execution when you create a binary. Okay, the first thing it does is it actually loads up the Lisp runtime. Okay, it does something called Lisp initialization. Okay, this Lisp initialization, when you start the execution of a binary, is essentially the same thing like when you start up SBCL. Okay, it's doing some sort of bootstrapping to kind of set up the Lisp runtime and prepare it to actually execute your application. All right. Then, just like any other assembly program, it looks for the entry point of your application, which you specify when you do when you do save Lisp and die. There's an argument that you specify to tell you what the main function is about. Okay. Hold on, is there? And then it will actually do your basic application execution. Okay, this goes fast enough that for in most Lisp, because they brought it down to fairly close to C initialization speed depending upon the application. But there is some overhead, as you can see here, to actually set up your Lisp application environment before the actual application gets executed. By the way, this same thing that you're seeing here is what JVMs and other virtual garbage collected languages that use a virtual machine style do. Lisp, Common Lisp, as well as its I would say spiritual sibling, Smalltalk, does the same thing. They have a virtual machine that gives you the ability to do some sort of initialization before your application starts. okay? The same thing is actually going to happen when we do Lisp library loading, all right? So what this is doing is it's doing nothing more than, again, Lisp initialization, and then it's going to load up the core file, okay, that you're going to specify. The core file is whatever you dumped from Save Lisp and Die, and it's then prepared to being able to take calls to actually execute your Lisp code, okay? And we're going to kind of show some examples on how to leverage this, okay? One thing that I'm going to bring up at this point is, to do this, you're going to have to first create a core file. And this is going to obviously bring up some at least hurt that I've experienced when I was generating this core file, and that is for whatever reason when you are building your Lisp, okay, one second, for some reason I think I was kicked out of one thing. Okay. Give me a second here. Yeah, it looked like I was kicked out of my own kicked out my own meeting. All right. One piece of, I would say limitation that I encountered, okay, when I was starting to do this exercise in preparation for today, is how to generate the core file, okay? When you're developing your Lisp library, and this is not so much a criticism of Sylvester and Slime, but it is something to be aware of. Generating a core file for this type of use case is a little bit impossible, because you'll end up getting an error when you're making a call to save Lisp and Die with the appropriate arguments that I'm about to show you. Okay, I don't know why. I don't know how to fix it. This is something that I'm new to in terms of my Common Lisp journey. So for folks who are aware of this use case and knows how to deal with it, by all means, put your comment in the YouTube comments and let me know, and I will certainly bring it up next time. But this is something that I'm just giving you a heads up, so ahead of time. So if you're wondering why I'm using Save Lisp and Die in SBCL in eShell instead of doing it straight in my Sylvester session, this is precisely why. Okay, I'm giving you that heads up ahead of time. This is a fair warning. All right, let me go ahead and show you what we're going to do today. Again, I'm focusing on just primitives because it's easier, but obviously as we start building into this and experimenting more in the coming weeks, we'll start using proper Lisp objects. But for the sake of today, we're going to stick with primitive types. So let me go ahead and create our library. Okay. Again, I'm going to call it mymath.lisp. Okay. Here, I'm going to go ahead and I'm going to start using, again, another warning. This is going to be SBCL specific. Okay. This is all SBCL specific code. Okay. Please do not get mad at me for folks who have been up until this point being happy that I was writing portable Common Lisp. Unfortunately, as I mentioned earlier, this is something that is very SBCL specific, and if there are other languages that do this, you know, I'm not going to focus on commercial Lisp. Tell me about other open source Lisps, and all the commercial guys. If you guys want to show off how to do this in your commercial Lisp, by all means, give me a call. or text me, and I'll let you present it, but I will not focus on it myself. All right. In SBCL, there's a thing called SBCL-Alien. As the name of the namespace or package indicates, it's to allow you to deal with foreign languages, and this is a historical package. So that they named it, but that is what it is. And SBCL-Alien is basically what's used by CFFI to allow you to create what's it? It's also used by CFFI to allow you to interact with your external C libraries with Lisp and load them up into shared memories. But one thing that CFFI did not export from SB-Alien that you can use with SB-Alien when you're trying to write common Lisp code that can interact with your outside world is something called define alien callable. Define alien callable allows you to essentially create what's called an exported symbol to the outside world, again using C naming conventions. And this is ultimately going to allow you to then create the function that ends up being called from your C code. Okay, so we're going to create our traditional add function. As you can see in my mini buffer, if you are following along, SBCL-Alien define alien callable takes a bunch of arguments: the name of it, the result type, a typed lambda list, and then the body. Okay, the result type is normally an SB-Alien exported type. I don't think you can use anything else beyond that. Okay, the type lambda list is the same thing. You can actually go ahead and do the same stuff. Notice I am using the exported symbol, the package name prefix before the exported type. You don't necessarily need to do it this way. I just tend to like to know where my types are coming from. And then you can just go ahead and write your standard Lisp code as is. All right, this is all probably fairly straightforward stuff for folks who are watching. One thing to know is that when you do a hold on, there's a question here. Someone cracked a joke here. Can you get an illegal? I don't know how to answer this question, but okay, I will. But yes, yeah, no comment is probably the best way to answer that. I'll go with that. So let's look at the macro expansion of this. So what SB-Alien define alien callable does is it creates something, a symbol, a Linux, well, a Lisp symbol called add, okay, because remember we're creating an add function. And then it generates in its global alien callables table the add hash that's then leveraged and set to a lambda function, a typed lambda function that contains the actual Lisp code that we're creating. And notice that we are using a unexported symbol there, alien lambda, to define an alien lambda function with the actual appropriate typed signature. Okay, this will tell you that although alien lambda is available there, it is something that you rather not use directly. All right, let's go ahead and compile this guy. So now at this point, you might be thinking that we'll be able to just run save Lisp and die here. Okay, but this is where things are going to get wonky. Let me show you the arguments and let me show you the error so you know what I'm talking about. So save Lisp and die here has a bunch of arguments that tells you what you're providing. One of which you're telling basically save Lisp and die, if you recall, when we talked about this when we're in through our ROSGOL series. It deals with whether or not you're dealing with an executable, what runtime options you want to specify. You can specify also, in this case, we're going to use the fourth option, callable exports, to determine what exported symbols we are creating. Root structures that you need to, whether or not you need to compress the core image or not, and so forth. And whether or not you want to purify. Purify, if I recall, it's doing some sort of optimizations behind the scenes to make sure you get as small of a core file as possible. But the main thing to note is callable exports versus executable. In callable exports, if you have that, if you're using that, you'll end up getting an error if you also call, say, executable, if I remember correctly. That is essentially kind of canceling each other out. So you can't make a shared library and an executable at the same time. So we're going to use callable exports to actually go and export this guy. Okay, and we're going to go ahead and also add, this takes in a list, and we're going to name, specify our actual symbols, all right? All lowercase, because that's what the hash symbol is actually generating at. And when we hit enter here, you'll see the error that we end up getting. No, not odd number key arguments. Give me a second here. Oh, right, because ROM forgot to specify the name, the path to our core file. Software projects, Lisp projects, let's call it hello.core, oh well, mymath.core. Okay. And you see now, cannot save core with multiple threads running. So what are these multiple threads? Well, it tells you what those multiple threads are. And all of those threads, the reader threads, link, slides, all related to our development session and hook up into Emacs. Okay? So this alone will not be able to do what we want. One way to handle this is obviously you could just create what I would do. I'll create here a new a script, a raw script to actually generate this. So let me open up eShell. Okay, and go up a level. We have a bunch of our stuff here, and I have my mymath.lisp there, as you can see. I'm just going to go and do a ROS init mymath.ROS. That's generating a build script that you could certainly use. And then we'll go ahead and open up mymath.ROS here. And what I'm going to do is you don't necessarily need now this stuff, but this is certainly somewhat useful. If you created a proper Lisp project, this becomes more useful, but in my case, I can actually probably just move the code from mymath.lisp into here. And all I need is here for it to do save Lisp and die, and let it generate for the time being. I'm just making it simple. Otherwise, technically speaking, since REST argv is actually a list, you can actually pass this as an argument, the path to your code, and it can do the same thing essentially. Callable exports. This, in fact, that's probably one way of generalizing it. All right. So now this is all done. Hold on. Let me first save it. Now, if I do ROS run mymath.ROS. Let's see. Oh, right. I to actually, this is actually a script, isn't it? So I have to actually run my math.ros by first creating, where is it? It's an executable, yeah. And let's see what it throws up. Defund main style undefined function save Lisp and die. Interesting. Hold on, I must have missed something here. Save Lisp and die is part of the same code. Oh, maybe I could just do this. If I do D3D, well, do this, and let's do. If you're wondering what I'm doing is I'm basically making this into an actual script where it just loads instead of creating a new package. Let's see if that works. Okay. Let's see. There we go. That's it. So now we have our mymath.core. Okay. So now we need to create a CPP file or a C file to actually use this. Okay. Now, before I continue, since we have only like 9 minutes left in today's discussion, I'm just going to briefly mention this piece here, and then I will end it for this, because this is going to go into a much longer discussion. Up until this point, I haven't mentioned how I'm actually going to be loading this shared library. Okay, I have a separate SBCL build that I downloaded from the mirror, the GitHub mirror that I built last night with the shared object stuff. In order for you to actually end up leveraging this or doing this stuff that I'm about to demo in your own projects, okay, you're going to have to build SBCL as a shared library. As far as I know, I don't think it comes with any of the Ubuntu packages or Debian packages, or it's not compiled and distributed as far as I can tell. Okay, at least I haven't been able to find a way of getting it. So I've posted in the YouTube description. Okay, I put in the YouTube description for today's discussion the the SBCL-Librarian cookbook stuff that I was hoping to get to talk about today, but it looks like it's going to probably end up going to next week. In there are actual steps to build this shared object. I encourage you to follow those steps exactly, because if you just use the native shell scripts, you will not build the shared object correctly, I guess, because what ends up happening is later on when we start talking about SBCL-Librarian, you're going to end up having to use ZSTD for compression, and by default, make shared library.sh does not build with ZSTD. That's the compression library that it uses. So I'm encouraging you ahead of time to go look at that stuff. Again, I posted in YouTube description. Please let me know if there are any other things that you may want me to encounter in that piece. All right, so let's see if I can, the time remaining, quickly get this piece going. So we need to first create a test CPP with this code. Okay. Let's see here. Let me just get this out of the way. Not this. So I'm just going to go ahead and load this guy, just to show you that we can at least load the file, and then next time I'll leave it at that, and next time we'll go and call out our function before moving on. Let's do mymath.cpp. Let's stick with mymath.c, and then we'll end up leveraging. Oops, wrong thing. Okay, you know what? Let me just get this way. mymath.c. There we go. And I don't need that, but I do need stdio. rv. Okay. So the one thing, alright, there we go, that we need to first do is we need to go ahead and specify our code to actually go ahead and build our, loading our actual initialized Lisp stuff. Alright. So initialized Lisp is actually an external symbol that ends up being leveraged later on. It's loaded in when you load in the SBCL library. So we're just going to go ahead and add that simple signature there to actually load that in. And we're going to create here an argument list that essentially is going to be passed in to load our actual library. Uniform? Yeah, I think that's what it was. And then we're just going to go ahead and load our arguments. So we need to pass in, not argv, args. Okay. There are 4 arguments there, so we need to pass in 4 args, and hopefully this alone should not cause any problems, but let us not. One second. Okay, and this is going to end up, hopefully, let's go ahead and put this around an actual equals 0, and let's go ahead and return a -1 upon error. This is all standard C code for most folks who have, who's written C. For right now, I'm not leveraging stdio yet. I don't think I need. I was planning on using this to just check to see if we end up. Actually, this is what I wanted to do. I wanted to start this out first, and then later on we'll call the functions later. Okay. Okay. So this is our basic idea. All right. So now we need to go and build this guy. To build it, we're going to have to first specify where SBCL is actually located. Okay. So SBCL source equals upper project. I'm using absolute paths here, so forgive me if this is getting a little, whatever. And I need to also specify that. And actually, do I need that? No, I don't need this. Hold on 1 second. This is only for if I need to get the source at the runtime. Alright. Okay, give me just 1 second here. I don't think I need that compilation. I think I just need to specify it in GCC, but we'll see if I need it. Yeah, I just think I just need to specify it here first. Home software projects Lisp projects SBCL source runtime. This is actually the location of where the actual SBCL object is, the shared object is. We're going to go ahead and compile this guy -shared, -shared, so that it doesn't complain about the initialized Lisp stuff here. Go ahead and do my math, and then we'll do my math.cpp-sbcl. Oh, not my math.cpp, sorry, my math.c. Oh, right. There we go. So we have our exe. To actually load this guy, we're going to have to use library path. Library path, just so I don't blow away anything that's already there. Okay, and then we need to provide, again, the location to where the shared object is. So this software projects, this projects SBCL source runtime, and we do my exe, and if this works, this did not work. Well, what is the segmentation fault about? That's the more important thing. Why is it getting a segmentation fault? Is it because it can't load the Lisp core? That might be the problem. So hold on, let me just check something here. Do I have SBCL here? Yeah, I do. Okay, so SBCL-core my math.core. Attempt to access undefined alien variable. Okay. No init form. Hold on. Okay, so it looks like the issue here is although I did save Lisp and die, there is some additional arguments I need to pass over to actually go and build the core file in order for us to actually build this executable. Okay. This looks like it's going to require a little bit more time than we have, since we're already over. We're going to do it looks like next week is going to be somewhat of a debugging session to kind of close out this and then introduce you guys to SBCL. I do appreciate all of you folks joining me. Any comments? I saw a comment about my font is very small. I tried to expand it as much as I can. Unfortunately, I can't control the multiple sessions here. I will make sure I try to get this into a presentation mode so that for folks who are watching all over in global setting. I have to switch between Emacs profiles, and and the number of buffers I open up is just massive. So I have to create a global setting in order for that to occur. My apologies. I will go ahead and account for that for next week with some global settings. Are there questions from our live stream audience? The Go stuff is going to be stuff that we're going to be covering next week to finish off the Go example. I was hoping to get to a Rust example. I didn't get a chance to do that. But with this Lisp, calling Lisp from C example, we'll be able to go full circle and be able to do a kind of a bi-directional call alien into Lisp and Lisp into alien and vice versa. And then this will give us new opportunities to interact in a whole new world. So that's kind of the plan next week, and I'm hoping at that time I will also introduce you guys to SBCL-Librarian, which gives you a lot of the stuff that I'm showing you from scratch, but I'm doing that to motivate you to look at SBCL-Librarian to understand what is available at your disposal if you want to use C and Python today, and hopefully maybe even contribute to that project to actually go in and extend it to multiple languages. So that's it for now. I appreciate you all your time, and talk to you guys next week. See ya. Bye.